You ever look at a rock, a really old rock, or a dinosaur fossil in a museum and just wonder, how? How do they know it's that old? It seems kind of like magic, right? Well, that's exactly what we're going to break down in this explainer, how science can tell time on a scale of millions and even billions of years. Okay, let's get into it.
So get this, scientists don't just say the Earth is old. They say it's 4.54 billion years old. And that's incredibly specific, isn't it? It's not a rough guess or a ballpark figure. It's a number that's backed by a ton of solid evidence, a real statement of confidence.
And yeah, that's the big question, isn't it? How can anyone be so certain about a stretch of time that's basically impossible for our brains to even comprehend? It's not just about getting a number, it's about proving that number is right, beyond any reasonable doubt.
Well, the answer is just, it's really elegant. It turns out nature has its own clock. It's a clock that's built right into the elements of the universe itself, and it starts ticking the very second certain rocks are born.
Okay, so the main method is called radiometric dating. The core idea is actually pretty simple. Some elements, like uranium, are a bit unstable. And over a long time, they naturally break down, or decay, into a different, more stable element, like lead. The absolutely crucial part is that they do this at a perfectly steady, predictable rate. So to track this decay, scientists use this concept called half-life. And it is literally what it sounds like. It's the time it takes for exactly half of a pile of radioactive atoms to change into something else. Think of it as the steady, reliable tick-tock of this amazing atomic clock. And this is a perfect way to picture it. So imagine a new rock forms, and it's full of nothing but uranium-238. The clock starts ticking. Now, we know the half-life of uranium-238 is about 4.5 billion years. So if you could come back in 4.5 billion years and analyze that rock, you'd find it's now a perfect 50-50 split. Half uranium, half lead. So by measuring that ratio today, you can figure out exactly how long the clock has been running. Pretty cool, right? Okay, so we've got this incredible clock. But what are we actually dating with it? What are scientists putting under the microscope to get these massive numbers? That's the next piece of this whole puzzle. You'd think the logical thing to do is just find the oldest rock on Earth and date it, right? Well, the problem is our planet is constantly changing. It's geologically active. Over billions of years, our original rocks have been melted down, squashed, and reformed over and over again. And every time that happens, their atomic clocks get reset to zero. So scientists have to be detectives. They hunt for pristine evidence, stuff that's been around since the very beginning of our solar system and hasn't been messed with. And meteorites? They're perfect. They're basically leftover building materials from when the planets formed. Scientists also look for super tough, resilient minerals right here on Earth, like zircon, that are so durable they can survive for billions of years without being altered. Now, when it comes to fossils, it shows you need different tools for different jobs. For organic stuff that's relatively young, like bones or wood up to maybe 50,000 years old, we can use carbon-14 dating to get a really precise, absolute age. But for the really, really old fossils, we often have to look at the rock layers they're trapped in. We can't date the fossil itself, but if we date the layers of volcanic ash above and below it, we can trap its age in a very narrow window. One gives you a direct number, the other puts it exactly where it belongs in the timeline. And this brings us to what I think is the most important part of this whole story. Look, any single measurement could be a fluke, right? So how do we get from a really clever technique to something that is considered an unshakable scientific fact? Well, the answer is all about building a web of certainty. It's a totally fair question. How can we possibly trust a clock that's been ticking for billions of years? The reason we can be so confident isn't because of one single discovery, but because of a careful, deliberate process of checking and rechecking from every possible angle. So, first things first, the very foundation of this whole thing is rock solid. The rate that atoms decay, that's a fundamental law of physics. It doesn't speed up or slow down with heat or pressure or chemical reactions. It is one of the most stable, predictable constants in the entire universe. It just works. And here it is. This is the real game changer. We don't just rely on one type of atomic clock. We have a whole toolkit: uranium-lead, potassium argon, and a bunch of others. And when scientists can use 2 or 3 totally independent methods on the same sample, and they all point to the exact same age, well, that's when your confidence just skyrockets. That's not a coincidence, it's confirmation. And the web gets even stronger, because this isn't just one area of science making a claim in a vacuum. You have physicists providing the fundamental, unshakable decay rates. You have geologists using their expertise to find the right samples and make sure they're not contaminated. And you have astronomers who look out at the cosmos and confirm that the age we're getting for our solar system makes perfect sense in the grand scheme of things. Each field basically peer reviews the others.
And finally, the process itself is just incredibly rigorous. Any qualified lab anywhere in the world can take a piece of the same meteorite, run the tests, and they will get the same result. On top of that, scientists are their own toughest critics. They're always looking for potential problems, like what if this sample got contaminated, or what if it was superheated at some point? And they know how to account for those things. This is how you build real, lasting certainty.
So when you put it all together, what you have isn't a guess. It's not a theory. It's a verdict. One that's been reached by following multiple independent lines of evidence that all point to the same conclusion. A verdict that is, quite literally, written in stone.
So to just boil it all down for you, we can read the age of our planet thanks to its own natural radioactive clocks. We figure out how old fossils are either by dating them directly or by dating the rocks around them. But the real, undeniable accuracy, that comes from the fact that so many different methods, used by so many different scientists, all agree.
If you take one thing away from this whole explainer, let it be this. Real scientific truth, the kind you can build on, it's almost never about one single magic bullet experiment. It's built, piece by piece, from all these different kinds of evidence that all point to the same single coherent story. And that kind of leaves us with one last thought, doesn't it? We've used these incredible atomic clocks to read the deep, deep history of our own world. What else can they tell us? What other mind-bending secrets of the universe are locked away inside these atoms, just waiting for us to figure out the right way to ask?